Hi, today we're going to be talking about how to find irrational numbers and what they are. So we're going to start by just talking about these perfect squares. So a number that times itself is a perfect square. So 4 times 4 is 16, 9 times 9 is 81, 16 times 16 is 256, 25 times 25 is 625, 14 times 14 is 196. I wouldn't worry about having it memorized, except for 1 through 10 would be a good idea to have memorized. Alright, as we're doing this, the side length of a square is where we're going to start, because we're talking about squares and square roots. And it literally, actually, those words come from the words from squares. So a square with an area of 1 means we just box off 1 square. So if I box off 1 square, you can see area is 1 times 1, and 1 times 1 is 1. Square with 2 units, that's going to be harder, we'll skip it. Square 3 with 4 units. If I make a box, it covers 4 units. This is 2, this is 2. 2 times 2 is 4, the area is 4. So if you have an area of 4, the square root of 4 is 2, because that's the side length of a square with an area of 4. And if you have a square with an area of 1, the side length is the square root of 1. That's the length when the area is 1. So then the question comes up for square 2. Can we draw a square with 2 square units? If you're watching this and trying to do this on your own, I want you to pause for a minute and see, can you figure out how to draw a square with 2 square units? Go ahead and take a minute and try. Okay, as you've tried it, did you come up with this? Ta-da! Half a square, half a square, half a square, half a square. 4 halves is in fact 2, and that is the side length. Now that side length, this is 1 and this is 1. We're going to call this side length right here root 2, or square root of 2, sometimes called radical 2. That's what a square root is. By definition, a square root is the side length of a square with a given area. That's the geometric definition. So a perfect square are those numbers that come out pretty. It's a number times itself. And there are going to be a ton of perfect squares. 1, 4, 9, 16, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, etc. Those are all perfect squares. A square root is when you say, hey, if the area is this, what is the side length? Sometimes square roots are referred to as radicals. You can write a square root like this. Sometimes they're written a little bit with that little more squiggly. Traditionally, computers will write this, but with different fonts. They're written a lot of different ways now, even with typing. A square root is the length of a side length given the area is any given number. Now a rational square root is when you take the square root of a perfect square, because square roots of perfect squares come out really pretty. They're going to come out nice. So if I were to take the square root of 36, that would be 6. If I were to take the square root of 100, that would be 10, because 10 times 10 equals 100. Irrational square roots are square roots of non-perfect squares, so they don't come out pretty. In fact, they come out so ugly that they just keep going forever and ever. Anything that is not a perfect square is going to be an irrational square root. So square root of 2, 1 is a square, 4 is a square, but square root of 3 is not. 4 is a perfect square. 5, 6, 7, 8 are not. 9 is a perfect square, so it would not be. So, which leads us to irrational numbers. We mentioned on the first part of this unit that rational numbers end or repeat. Well, irrational never ends and never repeats. So they keep going on and on and on and on forever. You've heard of some irrational numbers before. The first irrational number you've heard of is pi. We're going to take a side note for a minute and go off on irrational numbers because that's really something we need you to know. So, irrational numbers never end, never repeat. That is a definition I would absolutely have memorized. Irrational numbers never end, never repeat. With that definition, let's talk. Pi and anything that contains pi after you've simplified it, automatically irrational. Square roots that aren't perfect squares are all going to be irrational. If it's a perfect square, then it will be rational, but any other square root is irrational. So square root of 2, square root of 3, square root of 5, 6, 7, 8, 10, 11, 12, etc. Square root of 9 is rational because it's a square root. If you just have some mumbo jumbo number with no really pattern to it, and it just keeps going on and on and on, and we're going to use those dot ellipses, the dot dot dot, to indicate it goes on and on and on, that's going to be irrational. The tricky one that they like to throw at you is if you have something like this, and you're going to look at it, and you're going to say, well, this looks rational because there's a definite pattern. Patterns are not the same thing as repeating. Yes, it is a pattern, but it is not repeating. Repeating would be 4, 5, 4, 5, 4, 5, 4, 5, 4, 5. It is adding a 5 each time, so even though it's a pattern, it is in fact irrational because it never ends and it never repeats. Be aware of those ones, you'll see them. Okay, those are kind of the 4 main groups of what you're going to see at this level for irrational numbers. You do need to know the definition, and you absolutely need to be able to look at a number and say, is it rational or irrational? So let's just do a contradiction with rational. Rational numbers either end or repeat. Now, when I was first learning this, I used to learn it and teach it actually as numbers that can be written as fractions. That is true as long as both of the parts, if any part of it is irrational, then the whole thing is irrational. So if I have like 7 halves, rational, because 7 and 2 are both rational. Square root of 36, rational, because it's a perfect square. If I have 0.45 repeating, rational, because it repeats. 2/9, when you make it a decimal, repeats, so it's rational. Both of those are rational, so it's rational. However, if I have something like the square root of 7 over 3, 3 is rational, but the square root of 7 is irrational. So because it has a part that's irrational, it's automatically going to be irrational. Now, they could go tricky and do something like 5 pi over 3 pi. And you might be like, well, pi is irrational, therefore this is going to be irrational. But the pi's cancel out, and it's really 5/3, so it's really going to be just a repeating number, so it's going to be rational. So watch for that. Watch for, does it contain an irrational part? If after you simplify, it has an irrational part, it is irrational. But if after you simplify, all the irrational parts are gone, then it's going to be rational. All right, let's jump back over here. Okay, determine if each square root is rational or irrational. Square root of 6, not a perfect square, irrational. Square root of 3, not a perfect square, irrational. Square root of 7, not a perfect square, irrational. Square root of 5, not a perfect square, irrational. Square root of 8, it's not perfect, irrational. Square root of 4, oh, 2 times 2 equals 4, so that's going to be rational. Square root of 9, 3 times 3 equals 9, rational. Square root of 2, ooh, irrational. Okay, which numbers are irrational? Well, 25 is 5 times 5, so that would be rational. Square root of 50, that breaks down into 5 and 10. And 10 is equal to 5 times 2. That comes out, but it's going to be irrational because 49 is 7 times 7, and 64 is 8 times 8. 125. Square root of 125. What times what equals 125? No number times itself, so that's going to be irrational as well. All right, let's look at some of these ones. Decimal, it ends. Because it ends, it's rational. This one repeats, it's rational. This one keeps going. Oh, this is one of those pattern ones I was talking about. 2.010110111, irrational. It's got a pattern, but it's not actually repeating the number. This one, 1, 2, 3, 4, 1, 2, 3, 4, oh, it's repeating, so it's rational. 1.80333333 repeating rational. All right, which number is not irrational? 3202002002000. Oh, there's that pattern. It's irrational. 321321321. Oh, good pattern. Rational. 31212212222. Again, there's that pattern that makes it irrational. All right, so on your homework today, you need to be able to tell me, is it rational or is it irrational? Go back to this. Anytime you're struggling. Irrational, pi, square roots of non-perfect squares. Look for the patterns. Rational, does it end or repeat? If you can prove that it ends or repeats, you know it's going to be rational. Good luck.